Okay, so we're now into the second 40 marks of the paper. And we've done this one in a progress check as well. So Ysgol Fron Isa and Ysgol Caiwen are two very different high schools. One school is large and in a rural area. The other is small in a town. The town in which the small school is situated has many traffic-free cycle routes. So the town is cycle friendly. All of the year 7 pupils in year 7 to 10 were surveyed in both of these schools. They were asked the following questions. Do you cycle to school? If you answered no, would you like to cycle to school? The results were displayed in graphs as shown below. So this graph is for Ysgol Fron Isa. Each column represents 100% of year 7, 100% of year 8, and year 9 and year 10. The black represents cycle, so this is saying 40% of year 7 in Ysgol Fron Isa cycles to school. The grey is would like to cycle, and white is a different response. And then that's the same information for Caiwen. So we've got two different schools, but we don't know which one is the small school in a town and which one is a large school in a rural area. Which school and year group has an approximately equal split between the three categories: people who cycle to school, pupils who would like to cycle to school, and other pupils. So I'm looking for which one of these columns has roughly 1/3 of each colour. And hopefully you can see, and most of you did in the progress check, that it's this one on the end. It's year 10 in Ysgol Caiwen, where you've got roughly thirds, 3 equal parts. Circle either true or false for each of the following statements. There are definitely more pupils in Ysgol Fron Isa who cycle to school than in Ysgol Caiwen. So definitely more who cycle in Fron Isa than who cycle in Caiwen. That's false, because although it looks more, that may be the smaller school. So you can't tell, because they're not giving you numbers, they're giving you percentages, they're giving you proportions. So we can't tell, so that one's false. Both schools have pupils in each year group with no interest in cycling to school. Well, the no interest is, it's not black, it's not grey. So because every one of them in both schools has got a white part, that's true. Questions asked were biased. Let's look back at the questions. So a biased question is one that's forcing an opinion. Do you cycle to school? That's all right. If you answered no, would you like to? That's all right. It's not saying, don't you think we should be able to cycle to school? Wouldn't you agree that? They would be biased. There's nothing wrong with those questions. So that's false. Approximately 20% of the pupils surveyed in Ysgol Caiwen cycle to school. So Ysgol Caiwen is this one. That's 20%, that's 20%, that's a bit under 20%, but that's a bit over 20%, which balances out that. So that's true. That overall would give 20%. And then the final one, it is more likely that it is Ysgol Fron Isa that is the small school situated in a town. So the small school situated in the town has got many traffic-free cycle routes. So the one where the school where more or a greater proportion of the kids are cycling would be suggested is the small school in a town. And if you look at here, there's far more greater proportions of kids cycling in Ysgol Bron Isa than there is in Caiwen. So that is probably true. In January 2011, there were 1,200 miles of national cycle network in Wales. In January 2016, there were 1,400 miles of national cycle network routes in Wales. If the number of miles of national cycle network routes in Wales were to continue to increase by the same number of miles per year, how many miles of cycle routes would there be in January 18? So the growth is 200 miles in 5 years. So it's gone up by 200 miles in 5 years. So each year, and let's go back to junior school. You can do 200 divided by 5 any other way, that's absolutely fine. But just to make sure that we can do this. So I want to do, how many times does 5 go into 200? How many times does it go into 2? It doesn't. So then we go 5 into 20, which goes 4 times, no remainder, 5 into 0, 0. So it increases by 40 miles per year. So in another 2 years, it's going to increase by 80 miles. And the question, how many miles of cycle routes would there be in January 2018? So I'm saying it's gone up by 80. So I haven't answered the question. There will be 1,480 miles. So 1,480 miles. Why is your answer in 1 unlikely to be an accurate estimate of the number of miles in Wales in January 2018? So I'll read you out again some of the answers here. It's unlikely to be a constant rate of increase. It's not a uniform pattern each year. They can vary because there can be more one year than another year. It's a total over 5 years. Not the same miles every time. There could be more routes in different years. You just don't know what will happen because it's an estimate based on previous data. It may go up, they may run out of money. Anything like that will get you that mark. So for that question, there's 1 mark for Caiwen and 10. There's 3 marks if you get all of those right. 2 marks, any 4 of them right. 1 mark for any 3 of them right. For this one, there's 1 mark if we're seeing 200 divided by 5, and 1 mark for answering the question, and then an explanation mark at the end for any of those that I've read out. Question 9. William owns and runs dog kennels. His cost depends on the number of dogs in kennels. The running costs for 1 day are shown on the graph below. Why does the graph not pass through 0, 0? So if he's got 10 dogs in his kennels, then the running costs are £50. If he's got 20 dogs, and so on. But you can see here with 0 dogs, it's still going to be a cost. And that's because even if the place has got no dogs in it, it's still going to cost electricity, heating, paying somebody to be there. So you just want to be able to say, because of running costs, such as electricity, which is still needed even if no dogs. So something like that. Part B. What is the increase in the daily running costs for each additional dog that is kept in the kennels? So let's go back to our graph, and if there are 10 dogs there, that's going to cost £50. Let's figure out how much 20 dogs cost. So 20, each little square this time is going up 50 in 10 jumps. So each little square is £5. So for 20, I'm going to be at £90. So I want to work out what the cost is for each additional dog. So 10 dogs extra cost £40 more. Okay, so to go from 10 dogs to 20 dogs, it's increasing by £40. So 10 dogs extra cost £40. So each dog extra will be 40 divided by 10, £4. So it costs £4 per dog. Part C. Frida also runs a dog kennels. The cost of keeping 20 dogs in her kennels for one day is £130. Okay, so there's some numbers I need to use. She knows that as the number of dogs increases, the overall cost increases at the same rate. Display this information on the graph paper opposite. So we've got to go back to my graph paper now. And this is telling me that 20 dogs in her kennels costs £130. So 20 dogs, 130, that's going to be 125, halfway between 100 and 150, so an extra 5 on top of that. And this information is saying the overall cost increases at the same rate. Now what that means, if you think of distance time graphs, the faster something is on a distance time graph, the steeper it becomes. So if you've got something that's really fast, you're going to have a steep line like my pen. If it's slower, a slower rate, it's going to be flatter. If it's the same rate, it's going to be parallel. It's going to be the same steepness as the graph for William. So this bit of information here increases at the same rate, means it's going to be parallel. So the way to do that on your graph is line your ruler up with the line that's on there, and then you want to slide it carefully so that it doesn't twist until it's going through the point we've plotted. Okay, so you get your parallel line. And then part 2, find the cost of keeping 30 dogs for 1 day in Frida's kennels. So 30 dogs. Read up my graph and read across. So 150, 155, 160, 165, 170. Right, marks for that question. Explanation for something to do with electricity bills or heating bills or anything like that. Part B, a method mark for figuring out the change, how it's going up, and an answer mark for correctly getting £4 per dog. 1 mark for line going through the point. So 1 mark for making sure your line goes through that point there, and 1 mark for making sure it's parallel, and then 1 mark for the 170. Question 10. So we're into the B's now. Myrion is a window cleaner. From Monday to Friday, he records how long he spends cleaning windows for each of his customers. He draws a cumulative frequency diagram. Okay, so I'm thinking median, interquartile ranges, upper quartiles, lower quartiles. As soon as I see that, and I'm into grade B. Okay, so no questions on that sheet. Use Myrion's cumulative frequency diagram to find the median and the interquartile range of the times he spends cleaning windows. So the cumulative frequency is going up to 120. So it means I've got 120 pieces of data, or 120 customers, and the median is going to be halfway. So half of 120 is 60. So this is going to be my median, and I'm writing it on my graph, and then you read down. We need to figure out the scale. This is going 0 to 5 in 10 jumps. So 5 divided by 10, each little square, is a half. So I've got 15, 16, 17. So the median is 17. Then to find the interquartile range, you need to find quarter of the data below it and again above it. So if half is 60, quarter is going to be 30. So the lower quartile will be at 30, LQ, and that's going to be 14. The LQ equals 14. Then the upper one is going to be halfway between 60 and 120, which is 90. So we read that one off, and that one works out to be 19. So upper quartile equals 19, and then the interquartile range is the gap between them. So 19 take away 14 equals 5. Part 2. Myrion looks back at his raw data. That's crucial here. his raw data. He finds that the median is actually 17 minutes 30 seconds. Why is there a difference between the median from his cumulative frequency diagram and the actual median from his raw data? Now, when we were doing this back in September, and we were looking at cumulative frequency and estimating the mean of group data, basically as soon as your data has been grouped, you lose accuracy because you're estimating. Because he's got his raw data, he can actually work out what the actual median is going to be. So what you want to say here is something like, because the raw data is more accurate, or you could say because the cumulative frequency diagram gives an estimate. Or because the data is grouped, anything like that. Part B. Myrion is looking at the time it took to clean individual customers' windows. Find the number of customers whose windows took between 10 and 15 minutes to clean. So when you read off a cumulative frequency graph, it tells you less than. So when you read off 10 minutes, this is going up in twos, so that's 12 minutes, 12 people. What that's actually telling you is less than 10 minutes. So 12 people, he took less than 10 minutes. Then for 15 minutes, we go back here, and we go up to 15, and it's plotted on that point. And that's going to be 34 minutes. Sorry, 34 people. So the number of customers who took between 10 and 15 is the difference between 34 and 12. Which is 22 people. So 34 people took less than 15 minutes. 12 of them took less than 10. So between 10 and 15, there are 22 people. Part C. Myrion thinks that for approximately 80% of his customers, he cleaned their windows in less than 20 minutes. Is Myrion correct? Well, first of all, we need to work out how many people that is. How many people 80% is. So he's got 120 customers. Now remember, this is non-calculator. So find 10%, which will be divided by 10, 12. So 80% will be 12 lots of 8, which is 96 customers. So I haven't used the graph yet. I've just taken that 80% of his customers. Well, how many is that? Well, 80% of 120 is 96. So he thinks he cleaned 96 customers in less than 20 minutes. So what we want to do now is to see what we get off the cumulative frequency graph. So in less than 20 minutes, so we go across to 20 minutes, read up, and we have got 102 people. So from the graph, we've got 102 people, customers, which is approximately, it's not massively different between 96 and 102. So Myrion is correct. They are approximately the same, about 100. You don't need to put that in, but just to give you an idea, yeah, 96 would round to 100, 102 would round to 100, so that's good enough. Okay, marks for that cumulative frequency question, which hopefully you're quite happy with, because they tend to carry a lot of marks and don't take long to revise. So part A, 1 mark for the median, 17. A method mark for finding the upper quartiles and lower quartiles and taking them away, and an answer mark. Part 2, an explanation about why raw data is accurate and estimated data or group data isn't. A method mark here for finding the people at 10 and 15 and taking them away. An answer mark for 22. And then for this one, a method mark for finding out 80% of them. A method mark for reading 102 off the graph, and an answer mark for saying, yeah, he's correct. Okay, 2 more questions to go, I think. 3 more questions. 3 more questions. Megan Pugh's electricity bill is shown below. It covers the period May, June and July 2017. So the first thing to say about this is really unusual to have this on a paper 1. It's far more likely you get a utility bill on a paper 2, but just goes to prove that you could have this on a paper 1. So during May, June and July, the last meter reading they took was 1350. The present reading meter reading is 13900. So the number of electricity units used is what you get if you take those 2 away. So 450 units of electricity. The charge for the electricity, so she used 450 units and they costed 20 pence each. So you do 20 lots of 450 and that's how much it came to. Standing charge, 3 months at £7.60 per month. So 3 lots of £7.60 comes to £22.80. So the total charges are what you get if you add the unit costs and the standing charge together, £112.80. Then she gets charged VAT by finding 5% of that to come to £5.64. Total bill, £118.44. So they've basically done one of these questions for you to get you in the right place. Part A. On the 1st of August 2017, so that's the start of the next bill, because we've done May, June and July, August. The charge per unit of electricity was increased by 5%. What is the increased cost per unit? So the original cost per unit was 20 pence. Find 10% of that. You divide by 10, so that would be 2 pence. 5% would be half of that, which would be a penny. So it's being increased by a penny. So the new charge will be 21p. Okay, so 20 pence, find 10%, divide by 10, find 5% by halving it. Okay. Now what? Megan wants to calculate her next 3 monthly bill. She knows the following. Her meter reading on the 31st of October was 14,400. The charge per unit has increased by 5%, well, we've worked that out. Standing charge has increased by 20 pence per month since her last bill. VAT remains at 5%. On the 31st of October, Megan had £470 in her bank account. After paying her next 3 monthly electricity bill, will Megan be able to buy a new washing machine costing £330? You must show all your workings. Okay, so this is 9 marks for this question. Alright, so they're expecting you to have to work quite hard for that. Hence, the next page is completely blank. But all you're doing is repeating what they've done for you here. So the charge for electricity, the first thing we need to know is how many units she's used. So units used will be this meter reading, which is 14,400, less the previous meter reading, which is now 3,900. So we're going to do this subtraction. So 0 from 0, 0 from 0. Here I've got to change that to 14. So she's used 500 units. However you want to do the subtraction. And each of those units is going to cost her 21 pence. $500 lots of 21p. Well, let's not worry about the zeros. And let's do 21 times 5, which is 105. Then we can add on the zeros. And that would be in pence, because I've multiplied by 21 pence. It's going to be easier to work with in pounds. So to work it in pounds, we would divide by 100, which would give us 105 pounds. So what we've done there is this part. Okay? We've worked out the charge for the electricity. It's £105. Then we've got the standing charge. The standing charge has increased by 20 pence per month since her last bill. So it's gone up from £7.60 to £7.80. And we've got to pay that for 3 months. So I've got to times that by 3. Or add it 3 times, whatever you prefer. So 3 lots of 0, 0. 3 lots of 8, 24, 4 down, carry 2, 7 threes are 21, 22, 23. Where do we put the decimal point? Well, 3 7s are 21 pounds, 3 8s are 24 pounds, so it's going to be there. So the standing charge is going to be £23.40. So here I am now, total charges. So the total charges are going to be the £105 for the units plus £23.40. So which will come to £128.40. Then comes the VAT. So VAT is at 5%. So first of all, find 10% by dividing this by 10. You divide that by 10, the decimal point ends up one further to the left, so it would be £12.84. I want 5%, so I'm going to halve that to give me £6.42. So the VAT is £6.42. So the total bill will be the total charges, £128.40, plus £6.42. Which is £134.82. So that's her total bill. Let's go back to the question. After paying her bill, will Megan be able to buy a new washing machine costing £330? Well, she's got £470 in her bank account. So if I add on to that the washing machine, so cost of wash match 330, and add that on, I get 28464. So out of her bank account is going to come £464.82. She's got £470 in her bank account, so will she be able to buy the washing machine? Yes. So yes, she can. Nine marks, right, where do those 9 marks come from then? So there's 1 mark for getting 500 units. There's a method mark for your 500 times 21 pence, and an answer mark for £105. So if you've got no further, you can get those 3 marks. There's 1 mark for the standing charge of £23.40, and 1 mark for the total charges altogether. There's 1 mark for £6.42 VAT, 1 mark for the total bill of £134.82, and then a method mark for coming up with how much she's got to pay compared to what she's got in her bank account, which is off the page. So there was a lot of careful thinking to do there, which is why it's a grade B question. 9 times out of 10, that would be on a paper 2. Okay, we've got 2 questions left, they won't take long. Question 12, box and whisker plots. Something we did back in September and is not a big thing to revise. Okay, it's a grade B question and there's not much to learn about them. So Lena has 3 apple trees in her garden. She has 1 gala apple tree, 1 orange pippin tree and 1 pink lady tree. She picks 50 apples from each of the 3 trees and records the width of each apple as shown. Lena constructs box and whisker diagrams for the widths of the apples collected from each of the 3 trees. Now this is something we could have put on the formula bit at the front, but I forgot. With a box and whisker, this is all you need to remember. Is it on the screen? Yes. Okay, the parts of a box and whisker, that's your minimum value. This is your maximum value. That's your lower quartile, that's your upper quartile, and that's your median. And then each part of them represent a quarter of the data. So it splits the data into quarters. So in 30 seconds, that's everything you need to know. Complete each of the following statements. Apples from the blank apple tree have the least median width. So the median is the line that's inside the box. Which one has got the minimum median width? So it's this one. Yeah, that's the one closest to the bottom end. So the orange pippin has got the smallest median value. It's 57 compared to 61 compared to 63. So orange pippin. I can't spell orange now. And the median width of the apples, 57 millimeters. The range of the widths recorded for the gala apple tree. So there's the gala one. The range of the widths is the largest take away the smallest. So it's not the interquartile range, it's the range. That's the version of range you learned first of all back in sort of year 7. So it's the biggest value, which is 83. Take away the smallest value, which is 42. Take them away, and you get 41 millimeters. The blank apple tree has apples with the greatest interquartile range of widths. So the interquartile range is the length of the rectangle, the box part. So which has got the largest box? And I think by just looking at it, we can see it's pink lady. But if it's close, then you can just read them off. So upper, take away lower, or you can even measure them with a ruler to see which one's got the largest width. So it's pink lady. Off the screen again, sorry. It's the pink lady. The interquartile range on this tree, so to work out the interquartile range, it's the upper quartile, which is 79. Take away the lower quartile, which is 46. So that is 33 millimeters. Which tree has a higher proportion of larger apples? You must give a reason for your answer. So the higher proportion of larger apples. If we look back up here, because this cuts the data in half, into quarters, the distance between the median and the maximum represents half your data. So if we have a look at half of the data in the Gala, half of the data in the Gala is over 61. Half the data in the Orange Pippin is over 57. Half of the data in the Pink Lady is over 63. So the greatest proportion of wide apples would be Pink Lady, because half of the data in Gala is bigger than 61, half of the data in Orange Pippin is greater than 57, half of the data in the Pink Lady is over 63. So Pink Lady, because half of the apples are wider than 63 millimeters. Okay, so when it's talking about proportion, it's asking you about those quartiles or those halves. So easy one for that to mark. I'm looking for one mark, one for Orange Pippin on 57, one for the correct range, one for Pink Lady with an interquartile range, and one explanation there. And then we come to the final question. Now the final question is something we haven't covered in the autumn term when it comes to revision. It's just similarity. Okay, we'll definitely cover it in the spring, but we haven't had a chance to get through it over the last few weeks. Emlyn has a photograph that he wants to enlarge. A diagram of the original photograph and a diagram of the enlargement are shown below. Calculate the height of the enlarged photograph. So when you've got a relationship like this, where the shapes are similar, it means that every side has been increased by the same scale factor. So it's not the number of centimeters, it's how many times bigger. How many times bigger has this side been enlarged? Because this side will be enlarged by the same amount. So you want to work out how many times 6 goes into 15. So you can either figure it out, but in case you can't, let's do it junior school way. 6 doesn't go into 1, it goes into 15 twice. It goes into 15 twice with a remainder of 3. And then 6 goes into 30 5 times. So the scale factor is being increased by 2.5 times, which means that this is also increased by 2.5 times. So 4 lots of 2.5 gives us the height. And 4 lots of 2.5 is 10 centimeters. So if you see a question like that, as I said, we will practice it, that's what you're looking to do. You don't say, well, if that is 9 centimeters bigger, this is 9 centimeters bigger. You're asking yourself, how many times bigger is it? Okay, and that's that paper. Well done, folks.